Rotational work. This is in Unit 2 work under Mechanical Systems. And we're going to be taking a look at rotational work. Now, what does it mean when you talk about rotational? It means it's going to rotate or go in a circle. Alright, so that's what we're going to be looking at. So it's going to be going in a circle. And you're going to see that with mechanical rotational work, you're going to be looking at torque. Alright, we talked about that a while ago, torque. And it causes the mass to turn or rotate through an angle. Torque is a force-like product, I guess you could say. It's not considered force, but it's force-like. Not a prime mover. They still consider force to be prime mover, but this time, like when you say torque, if you remember, torque is force times the lever arm. Right, that goes back a while, and we're going to be dealing also with angles. That's going to be our primary goal here today. All right, and here we have a gear, and the gear would turn around. All right, and the way you'd remember how you would do torque is from the center to the edge. That's going to be your lever arm, or L, and then how much force is applied to turn it. That's going to be your torque. Alright, now a unit that you have to get used to is what's called a radian. It's an angular measure. They use RAD. Alright, not to be confused with a rad with nuclear physics. Alright, but that's the way a lot of times they'll write it. And what exactly is a radian? You know, like on your calculator, you have degrees or you have radians. They're the two choices that you can put your calculator in. Well, you have a picture here of the Ferris wheel, and basically what a radian is when you get your radius. Okay, one of these bars would be the radius of this wheel. Here's the center. All right, here's more or less the edge. When this radius equals the same amount of arc, all right, probably to about here. All right, and you measure this degree right here, from here to here, it's going to be 57.3 degrees. So that's a radian. That's the actual definition of it. When you have the radius is equal to the length of arc, then the degree between, okay, these two radii are going to be 57.3 degrees. Alright, we're going to put all that together, but we've got a couple things to do first. Just a reminder of old stuff. Remember, torque is force times lever arm. I mentioned that before. Your torque is going to be measured in either, and they like to use pound-feet rather than foot-pounds, so you can differentiate between torque and work. In the SI, it's going to be Newton meters. Force is in pounds in English, newtons in SI, feet in English, and meters in the SI. And so when you combine these two together, multiply them, you get pound-feet. When you multiply these together, you get Newton meter. Now, they do not do a switch in the SI like they do the English. Not sure why. All right, but they do not. You don't see the switch. They don't even talk about it. Okay, what about this work? All right, we know how to find torque. All right, we're going to multiply torque times theta. Alright, so think of it in terms of this. We said about work was force times distance. This is your force-like quantity, and the angle, or theta, is going to be your angular distance. So let's take a look at our units. Work is in foot-pounds. Torque is in pound-feet. Alright, so that, like I said, when you're reading a problem, you can differentiate the two. And look what theta is in. It is in radians. So you're going to have pound-feet times radians is going to give you foot-pounds. And then in the SI system, your torque is going to be in Newton meters times radians. It's going to give you Newton meters. It's almost, radians is almost, it basically disappears when you use it. Now, the only other way around, if you didn't want to use radians, is that's when you have to use trigonometry. You'd be using sine, cosine, tangent, and so forth. All right, but you're not required to have that for this course, so we're going to be using radians. People who have jobs that they have to figure out work and and angles and torque. That's what they do. This is another method. All right. The thing is, when you have a higher math, you can do things a lot more accurately and more efficiently, quickly. All right, to figure out answers. But we're showing you kind of the basics here. So radian is our choice. Okay, here's if you want to convert. All right, you can't leave degrees. Okay, since you're not using trig functions, you can't leave it in degrees. You got to change it to radians. And the two choices you're generally going to have, it's going to be either in degrees or it's going to be in revolutions. All right, now what is a revolution? A revolution means one time around in a circle. That is a revolution. All right, so if you're looking at a flywheel, all right, or a pulley, it goes around so many revolutions, how many complete circles. All right, well, let's go back to degrees. What happens if you are given a degree? You want to convert it. So what you're going to do, remember we talked about this before with ratios. 1 radian is equal to 57.3 degrees. Since they are equal, I can put it into a fraction or ratio. All right, because 1 radian equals 57.3 degrees. That's actually equal to 1. Since I want to get rid of degrees, I had to put the 57.3 degrees on the bottom. Radian is what I want to end up with, so that needs to go up on the top. So if you take 360 degrees and you divide it by 57.3 degrees, you are going to be left with 6.28. And the unit, all right, degrees cancel out, the unit you have is radians. Now this is a significant number. All right, if depending on how far you are in math, did you ever have to describe a circle? All right. Well, let's first start by thinking along the lines of this. You know what pi is. It's 3.14, right? Where a whole circle is described as 2 pi. So what is 2 pi? Well, 3.14 times 2 is 6.28. Ha! There is a relationship here. All right, that's important to remember. So 2 pi is 6.28. So if you've learned that in your other math courses, this is one of the places it's being used. So 1 complete revolution is 6.28 radians. Okay, well, what about some other things? What if it wasn't 360 degrees? What if it was less, 40 degrees? You're going to use the same ratio. You want to get rid of degrees, so 57.3 degrees goes on the bottom. So 40 divided by 57.3 is 0.69. You want to end up with radians. All right, so that's going to go on top, and you get 0.69 radians. Okay, so back to talking about 360 degrees. It's 1 revolution. It's equal to 6.28 radians. Let's look at this one. Let's say you have 10 revolutions. All right, we now have another ratio that we can use. All right, it's 6.28 radians divided by 1 revolution. They are equal. This whole ratio is equal to 1. Revolution goes on the bottom. All right, so you're going to be 10 times 6.28, and you're going to be left with 6.28 radians. That easy. Most of the time you're going to be dealing actually with this one here. So you just have to remember, if you have a revolution, you're going to be multiplying it by 6.28 radians per revolution. And you get radians. Okay, let's take a look at an example. We have a simple machine. You have a winch. It has a crank handle that's 1 foot long and has a force of 20 pounds. And is required, 20 pounds is required to turn the crank. How much work is done in turning the crank through 5 revolutions? All right, couple key words in here. We've got 5 revolutions. We need to change that so that it's into radians. And then when we have that into radians, then we're going to have to use the work equation. So this is the first one we're going to look at. Torque is equal to force times the lever arm. Work is equal to torque times theta. Okay, so torque. The handle is 1 foot long. The force is 20 pounds. That's your force. The 1 foot is your lever arm. All right, because the handle goes from center and your hand is out here. So it's going to be 20 pounds times 1 foot is going to give you 20. That actually should be pound-feet, okay, rather than foot-pounds. And then the next thing you have is work equals torque times theta. Well, before you can do that, you take the 5 revolutions and you're going to multiply it by 6.28 radians per revolution. Revolutions cancel out. Radians is going to be your unit. 5 times 6.28 is 31.4 radians. Once you have that, you're going to take torque times your theta. So 20 pound-feet times 31.4 radians is 628 foot-pounds. All right, well, that wraps up your rotational work. You're going to be practicing radians, and you are going to be practicing finding work in a rotational system. By the way, angular and rotational are used interchangeably. So if you hear angular, if you hear rotational, they're actually meaning the same thing. All right, well then have a good week.